Hi guys, my name is Clara Hawkins and today I'm going to be walking you through my experiment of a folder falling at an observed velocity and how those results compare to models with and without drag force. In this experiment, I wanted to be able to observe the impact of drag force on a slowly falling object. The data from the tracker and the code will yield models that depict the observed position versus time, the position versus time when gravity is the only force acting, and the position versus time when gravity and drag force are acting. We can expect to see a large disparity between the model with only gravity and the actual model, since drag is an upward force that would slow the velocity of the falling folder. There are a few fundamental concepts that we need to understand in order to grasp this experiment. First being Newton's second law. It says that F equals ma. This is applicable because when mass is constant, if the acceleration isn't negative 9.8 meters per second, we know there must be another force acting other than gravity. It is helpful to know the formulas for gravitational force and drag force, as it will become helpful when writing the GlowScript code. I define the system as the empty folder that I dropped, and the surroundings are the floor, air, gravity, and anything else in the room as pictured. For later reference, I was holding the folder at 2.31 meters above ground, and I released the folder with no downward velocity. I set up the experiment by first finding a light object with a large surface area to maximize the effects of the drag force. I let the folder go with no downward force and then recorded the movement until the folder hit the floor. To analyze this video, I weighed the folder, used my height to scale the video clip, set the axis with the starting point being the origin, and then assigned a point to each clip. To begin the analysis, I first had to find the computational experiments graph through GlowScript code that I'll describe in the following slides. Once this was done, I transferred both the GlowScript position time points and the tracker position time points into a spreadsheet. Then I inputted these data points into a scatter plot so the slopes, or the velocities, of these lines could be compared and checked for accuracy. To find the position time graph for the falling object with no drag force, I edited the GlowScript code to account for mass of the folder, the starting conditions I explained earlier, time in between the frames, and the updated velocity, and position formulas. To the right is the graph yielded from this. For the model of gravity and drag, I first had to alter B to match the actual final position and the predicted final position. I also added the necessary equation to calculate my drag force and kept all other conditions the same as in the previous code. The graph of the results is shown to the right also. This slide depicts the data from Tracker and GlowScript that was used for the scatter plot. Feel free to pause for further analysis, but the results will be shown more clearly in the graph later. From these codes, I collected the data points and graphed them so the velocities could be compared. As you can see, when drag force is present, the predicted is much closer to the actual. However, there are still some errors due to this being an imperfect experiment. There was some horizontal movement as the folder dropped, making it harder to track precisely, and it's possible that there were other small forces at play. If drag force is balancing out the gravitational force, it means that there is no net force acting vertically on the object. This is because drag force is upwards and gravity is downwards, so if they are of the same magnitude, they'll balance each other. None of this graph shows a stable velocity, which would be the case if there was no net force. However, as the slope of the position time graph starts to stabilize at the end of the drag and gravity graph, it is approaching terminal velocity and likely would have reached it if it was allowed to continue falling. Terminal velocity would be the same regardless of initial velocity, as seen in the equation for terminal velocity, as there is no impact from speed. Also, this can be checked by adjusting the GlowScript code, and there is still no effect.